I think all aspects of this unit, astronomy, are just amazing. And so here we get to talk about the moon, the amazing moon, Earth's moon. And I think I mentioned before that with Earth's tilted axis of rotation, that 23.5 degree tilt, that probably was because it got whacked early on when there were kind of random things running around the solar system that hadn't become a planet. So something about the size of Mars probably struck the Earth, not only tilting it, but also taking some of the Earth that was forming, and some of that stuff sloshed into outer space and ultimately became the moon. So kind of from left to right, here we have the impactor right here, and then here we have the material sloshing out, and here you kind of see that material actually is going to form the moon. And there are some characteristics of the moon that are very similar to Earth's crust. And so I just think that is so cool. And this idea of the Earth getting hit by something the size of Mars is actually consistent because there was a lot going on, that what we call the heavy bombardment period shortly after the sun turned on, some 4.6 billion years ago. And we're going to see that the moon is relatively cratered. It's got a lot of craters on it. It's not, the Earth would have had a lot of craters on it, but the Earth actually was geologically active and has resurfaced itself. It's also resurfaced itself due to erosion with wind and water and that sort of thing. But the moon, back to the moon actually has a feature. I tell students it's kind of like when you barbecue, when you use charcoal grill, that stuff that's left over after you're done barbecuing, that is like regolith. So regolith is actually kind of the soil on the surface of the moon, and that regolith is caused by the moon being pulverized by micrometeorites. Beautiful picture of the moon, and I want to kind of point out some things with regard to craters. Here we go. Sometimes I call them, let's see, the ejecta blanket. Do you see kind of this stuff going out like that? Okay, that's the ejecta blanket. Basically, at the time of impact, the stuff went up in the air and then kind of fell out like that. That's the ejecta blanket. Terrace sides, a good example of that, can maybe be seen over here. Kind of see this. It's like a terrace. It's kind of like mini steps going up. Then the other thing, I sometimes call this the belly button, a central peak. So here's a central peak here. And most craters actually have a central peak. Here's a central peak, and they were formed at the time of impact as well. So if you're looking up at the moon, you're probably used to seeing kind of these dark regions and the light regions. The dark regions are called mare, and it's thought that actually mare were formed as before the moon actually solidified. What was happening, it was started to get across, and then basically it got hit by meteors enough to break the thin skin, and so it basically kind of resurfaced itself. So that's mare, nice and smooth. And then kind of these light regions, okay, those are the highlands. You can kind of see some craters here and there. The highlands are older than the mare. And then we have another feature on the moon, and we've seen it on actually other planets, like I want to say Mercury, maybe Mars, is a rill. So I don't know if you can kind of see this kind of line right here. It's a little cliff that basically, as the moon cooled, it kind of joggled, it kind of split right there.